We are live. Welcome in, brothers. Tonight we are stepping into the workshop lab to break down the single most critical residential service milestone: upgrading a home from 100 amp to 200 amp panel configuration. A lot of green helpers and standard installers think you just swap and pull the wires. But if you don't know how to calculate your service entrance, conductors, multipliers under Ontario Code Table 2 and Table 4, you are going to choke your amplicity, melt your wires. Choke your amplicity, melt your insulation, shut down by the inspector, and get your project completely shut down by the inspector. Tonight we are pulling back the cabinet layout on our custom panel board to break down overhead versus underground consumer service calculations, roof mass, code clearance, and the exact steps to pass a roughing inspection on day one. Drop your panel swap questions in the comment section. Clear your benches and let's head straight to the whiteboard math. Choking your wire size on a service upgrade is a major fire hazard and an automatic inspection rejection. So we are going to jump in right now. I'm actually following a schedule here. So right now we are live here tonight for all those who are tuning in. Thank you guys for tuning in to the live stream. So tables 2 and 4 is what we're going to be pulling up right now. So I'm going to head to my screen and I'm going to pull up table 2 and 4 here for you guys to show you guys what a table looks like. Just give me a second here for all those who are tuning in. Let's see if this is it here. Okay, so that is tables. Let me see. Stephen Hall. Thank you for checking into the live stream. Also, thank you for the contribution towards the channel and making a donation. And tonight we're going to, I believe, if I can, tables 2, it looks like. So basically, that is the, I'm going to read it off for you guys here. Hopefully I have the right table here. Again, I'd like to thank you guys all for tuning in to tonight's live stream and for taking the time out. So let's get into tables 2 here. I'm going to try to pull it up on my phone so I can actually read it off for all those who are tuning in tonight. So let's see. So if that is tables 4, tables 4 is amplicity. I hope that is tables 4 here. Can't really see on the screen here. So amplicity for not more than 3 insulated aluminum conductors rated not more than 500 volts and unsheathed in raceway or cable based on an ambient temperature of 30 degrees Celsius. C Rules 4-004, 26-142, 42-008, and 42-016. So in this table, it's basically going to show us the amplicity. It's basically going to show us all the way on the left-hand side. 12 is your size wire, number 10, number 8, number 6. It shows you the amplicity, which is if you're going under 60 degrees Celsius, 60 degrees Celsius. Normally, we will use for 200 amp anywhere from a 3 up to a 4 up. So we're going to see what 75 degrees takes us to. 75 degrees basically takes you to 155, 75 degrees. That's if you're going to be using a panel of 75 degrees Celsius. And also it tells you with 90 degrees Celsius, your ampacity can go up to 175 degrees Celsius. So basically that is tables 4, and that is how you get to your calculations. You also have 90 degrees Celsius, tables 90 degrees Celsius, also tells you number 12, and it's basically giving you the ampacity for not more than 3 insulated aluminum conductors. So again, this is aluminum conductors. So we're starting off with table 4 for all those who are tuning in to the live stream today. Again, I'd like to thank you guys all for tuning in to the live stream. So that's 75 degrees. You have 60 degrees, 75 degrees. You have 90 degrees Celsius. Most of us, we use 75 degrees or 90 degrees Celsius. So again, these are the ampacity. I'm going to switch right over to the other one now. Again, I'd like to thank you guys all for tuning in to the live stream. Don't forget to leave a like on the channel as you guys enter. So I'm going to switch to the other tables here. And let's go into the other tables here for you guys here. So I'm going to go to tables 2 right now. So this is going to be tables 2 I'm going to be pulling up here. And tables 2 basically, so these are the tables that we're going to head to try to do our calculations when it comes to our ampacity wiring of 200 amps and so on. So tables 2 go on to say ampacity for not more than 3 insulated copper conductors rated not more than 5,000 volts and unshielded in raceway or cable. So this is copper conductors right now, and it also tells you based on an ambient temperature of 30 degrees Celsius. See Rules 4-004, Rules 26-142, Rules 42-008, and Rules 42-016, and Tables 5A, 5C, 19, and D3. And again, your conductors on the side is showing you 14, 12, 10. And we're going to go up to what's going to give us 200 amps. So a 4-aught in 60 degrees Celsius will give us 195, and in 75 degrees it's going to give us 230. In 90 degrees Celsius it's going to give us 200 amps. So we want to land at 200 amps. So we're going to go with a 3-aught. A 3-aught, which is the 3 zeros, will land us 75 degrees exactly at 200 amps. So that's basically where you head over to basically take care of your wiring services when you are about to service the homes. So under the OESC, a standard 200 amp single phase residential service requires checking your termination temperature readings. Typical 75 degrees copper conductor under tables 2. Exact steps to pass a roughing inspection on day 1. Drop your panel swap questions in the chat right now. Clear your workbenches and let's head into it. So we're going to head over to the, let's see here. So again, under the OESC, a standard 200 amp single phase residential service requires checking your termination temperature readings. Typical 75 degrees Celsius. Copper conductors under tables 2. You are forced to run 2-watt to safe carry 200 amps for aluminum under tables 4. You must step all the way up to 4 to hit that same baseline rating. Drop a 200 in the live chat box right now if you prefer pulling copper over aluminum on your tight service upgrade. So we're going to head over to the panel that got installed here. And what this is a 125 amp panel, okay? And as you can see, the way I fed my wires, okay? I came down, you've got the green cable, which is for the actual bonding if you're going to be coming in from underground. Your underground service usually requires a ground wire. You put your ground plate underground and then you pretty much come off of your ground plate. You come into the panel. As you can see, as you can see right here, this is the ring right here.
What is this going to be for? What are you going to use it on?
Up here. As you can see here, I've got my white screws here, okay? This is basically attached to...
I forgot how this works.
Okay, I'm on the live, buddy.
Oh.
You've got the ring screw right here. You also have this right here, which is your lugs. You also have your ground wire coming in. So basically what this ground wire does, ground wire goes over to the underground. This ground wire goes over to the actual underground service, which is going to go onto a ground plate. This is my service wires conductors coming in.
How did I hear you?
Yeah. This is my service conductors coming in here.
How did I hear you?
This also is, as you can see, this lug here, this lug is burnt out right here. And this lug here, what happens is it's melted. For all those who can see right here, it's a melted lug right here. Obviously, I cannot use this panel anymore. You can see how I take my copper, I strip my copper wire by code, okay? I cannot have too much of this stripped out, okay? And my two hots will land here. Obviously, this is a bad panel. So this panel is either I remove this breaker in order for me to use this panel again. I don't know if you guys are seeing in between here, there's a busted lug, which I can't use.
This is 4 blocks wide. What the fuck?
What a life, dude.
I want to go to the fucking park.
So again, welcome back to the channel. Thank you guys all for tuning in to the live stream. So as you can see, this right here is taped with white tape. In order to identify my neutral, I have to tape this with white tape. And you can see right here, these are my two hots here, ties into here. So basically, that's how you go about installing a residential regular 200 amp panel, 300 amp panel, 400 amp panel. A lot of the panels are not going to have the lug situation like that, depending on the the panel itself. So again, you are forced to run a 2-watt to safely carry 200 amps for aluminum under table 4. You must step all the way up to 4-watt to hit that same baseline rating. Drop a 200 in the live chat box right now if you prefer pulling copper over aluminum on a tight service upgrade. So again, as you can also see how I bend my cable, okay? You want to make sure that you have your cable bent correctly. You don't want, when you install your panel cover, you want to have as much clearance in this area. You don't want these wires touching the panel, the wires at all. And also, as you can see, why I use the green wire instead of a regular copper cable. You would have, you're forced to insulate this cable here if it was a regular copper cable. So always remember, if you are going to be dropping your cable in as a ground wire, bound in, you have to have it insulated. All means it's a requirement. You cannot just drop a bare copper down this sleeve right here. Okay, and as you can see, if you're coming into here, you have to use Gromex. You also have to make sure that when you're dealing with your wires, your bounding wire and so on, that you're coming from the top of the panel and it's going into the top. It's not coming from the side. That will make you fail inspection instantly. So copper, you cannot have a bare copper coming in from the top. It has to be a solid green wire or it's going to be tape. And also, you have to come in from the top. Here, there's a screw right here. That's basically for if you're going to be going on to another panel, you're going to use that as to ground and go off to your other panel. And that's how you go about installing a 200 amp upgrade or a 100 amp, whether it be, that's basically how you go about doing that process. So we're going to get into overhead service. So for all those who've missed the live stream, the beginning of Stephen, okay, sorry Stephen, I didn't see you left a comment here. National Electrical Reference Table 310.15b 16. No more than 3 current carrying conductors. That's in the national. Okay, got you. C.U wire cost more than aluminum wire cost is the key factor. Yes, aluminum is a lot less than copper, and again, most people will prefer to use aluminum over copper because copper is more expensive.
Shut up!
Copper is more expensive and so on. So what I'm going to do right now is I'm going to be showing you guys this right here. What this is an overhead. It's an overhead service mass, and basically this is again for a 200 amp service. And again, when it comes to 200 amp service, I'm going to put up something on the screen right now for those who are tuning in. I'm looking for, let's see here, anything that, okay, so this is basically an overhead. This is what you get with an overhead service. Basically, you're going to see what I'm showing you guys here is overhead service when you're going up through the roof and so on. So this is where you get your overhead stuff from. Again, I'm going to shift back to some of the rules here also for all those who are tuning in to the live stream. So this is again an overhead service. That's the layout of how you go about with your overhead service. And so I'm going to take that off the screen. So again, these are the components for the overhead service. Okay, here also. Okay, this will go on to the side of the building or the home this way and or this way, whichever way, and they're going to use it to hold up the wires, guy wire that would go on here. So it's going to slide into here and loop around. So that's what that is. And what I'm going to do right now is I'm going to pull up the code book here for those who are tuning in. Let's So let me pull that up on the on my screen here, so I can actually read that rule there for you guys. Here. So it goes method of terminating conductors or cables at consumer service. The supply end of the consumer service shall be equipped with a service head that is suitable for use in a wet location except as provided for in subrule 2 and 3. Where service cables are employed and are continuous from the supply service to the service equipment, the service head requires by subrule 1 shall be permitted to be omitted when single or multi-conductor cables are employed. The service head required by subrule 1 shall be permitted to be omitted, provided that the cable terminates in a cable termination suitable for exposure to the weather, or the cable ends are sealed with self-sealing weather-resistant thermoplastic tape or heat-shrinkable tubing. Both single and multi-conductor cables are bent as necessary so that conductors emerging from the seal point of the cable termination point downwards and the cable are held securely in place by a clamp. Fitting or cable termination. Conductors of different polarity shall be brought out through separately brushed holes off the service head. The service head is what I just showed you guys. Conductors of different polarities shall be brought out through separate brush holes of the service head. Consumer service conductors shall be installed as specified in Rule 6-3023. The overhead supply conductors or cables and the consumer service conductors shall be arranged according to the requirements of Rule 6-116 to prevent moisture and water from entering service rails, cables, or equipment. Consumer's service head location. The consumer's service head or equivalent shall be installed in compliance with the requirements of the supplier authority and in such a position that the point of emergency of the conductors from the consumers or equivalent is a minimum of 150 millimeters and a maximum of 300 millimeters above and a maximum of 600 millimeters horizontal from the support for the attachment of the overhead service conductors of cables. So what I'm going to do here is I'm going to run a short video here before I continue here. For all those who are tuning in, I'm going to run one short video. So again, this is the conduit that I'm going to be working with today. And as you can see here, I've got my core line cutters, I've got my tape. Core line cutters, I normally use them to cut my PVC pipe ends. And as you can see with the pipe here, I've got basically tape at the end here in order to stop the gravel from going in. And basically what I'm going to be doing is running this PVC conduit to the other end of the wall. And I'm basically going to snip this off like this with my core line cutters. And I'm also going to place some tape at the end of the pipe. That way it doesn't get gravel inside of it. This acts like a coupling, same thing. This is how they come, 10 length. You'll get the, some guys call it a bell-end, but this is what you call a half-inch coupling also. Normally what I do at the end, I'll place around my glue around here. That way it's firm, secure. Twist at the end to make sure it's not moving. That piece is done. And then we're going to move on to the other piece. Now I need. Yes, Stephen. RT230 service 230.9.230.22 part 2 overhead service conductors. 230.24 clearance. 230.24 A-B vertical clearance for overhead service conductors. So what Stephen is referring to is the NEC reference for all those who are in America and are tuning in to the live stream. So I've given you the Canadian version. This in the chat, what's in the chat, that is the American version. So if you want to follow along, you can follow along with what is in the comment section. Again, thank you guys all for tuning in to the live stream. Don't forget to leave a like on the channel. So what I'm going to be doing is pulling up another clip here for those who are tuning in. Let's go with another clip here. Not that one there. That's just a diagram there for those who are tuning in. Let's go with this one here. That look like section one. Okay. That look like section 6 right there. So we're going to read off section 6 really fast here. Rule 6-102, the supply authority should be consulted on the number and location of supply service. Rule 6-112, clearance for overhead conductors in this code apply under the conditions existing at the time of installation rather than a maximum sag and therefore greater than but consistent with the clearance specified in CSA. Rule 6-112, it is not intended by this sub rule that an attachment point be provided for conductors other than supply or consumer service conductors. Where an attachment point is protected for conductors than supply or consumer service conductors, this application provision of section 12, 54, and 60 shall be applied. Rule 6-1125, components that meet the requirements of CSA. And it also goes on to say tubular support members, support clamps, roof plates, supply service attachment, service entrance heads, and support member termination. So that is section 6 for all those who are tuning in. I'm going to run another video here just to recuperate here. Again, I'd like to thank you guys all for tuning in. So let me run a short video here again for all those who are tuning in to tonight's live stream.
Really, to bring power into the home. So I'm going to go over to the actual hole now where they're actually so this is basically the machine that we use. That's basically a structure that he's doing. And as you can see, he's going to be placing over to the actual pole where he's got to go. Basically the type of machine that he's using. Basically sucking away at the dirt. And I'm assuming that he's already drilled through from one side to the other. And what you're basically doing right now is pulling the conduit over to the other side. Again, from time to time, you'll see me filtering my video to avoid having the other workers on the line. So I'm going to go up a little bit closer. So this is the machine that we're basically using across. Basically, he has to get to here. And he's got to get up to this pole. As you can see now, they're basically pulling this pipe over to the other side. As you come in, you can hit the like, share, and subscribe button. You can also leave a comment in the comment section. You can also leave a comment in the chat. So basically that pipe has to get its way over to here.
So again, welcome back to the channel. Thank you guys all for tuning in. And today what we're going to be doing is I'm going to take my thermal, my digital infrared thermometer, and I'm going to shoot this at the, I'm going to shoot this, let's go on the log here. And as you can see, it's not going to be moving at all. Let's test the panel, neutral. So basically, that's how you would test to see if your wires will be overheating. You just slide the right dot on here, and it's going to give you the temperature on it. So with the LUTs also, with the neutral bars also, same process. You can also go into here. That's where your breakers are going to be landing. So pointing this will basically give you the temperature pretty much. And that's how you go about it. So breaking down local utilities and OESC clearance height. Again, you have to have a clearance height when it comes to the utility company. Make sure that you're within the clearance to handle heavy overhead consumers drop weight and avoid mechanical snapping during windstorms. Also, the pointer attachment also has to be secure if you are coming onto the side of the home. For instance, if there's no point to go through the roof, you're going to do a stub 90 down here in Ontario, or you're going to go through the roof with a flange and everything on the with the proper stuff, prevent rainwater from dripping straight down the inside of your service pipes. So again, I'd like to thank you guys all for tuning in. I'd like to thank Stephen for tuning in to the live stream today, for the comments that was left. Again, and also thank you for the donation. National Electrical Code Reference Tables 310.15b 16. No more than 3 current carrying conductors. Stephen also said C.U wire costs more than aluminum wire, is the key factor. And he also went on to say RT230 service 230.9, 230.22, part 2 overhead service conductors, 230.24 clearance. B, vertical clearance for overhead and service conductors. So again, that is basically so size your service lines to rule. Watch your installation temperature and look down your lug spaces. Landing single phase residential means it's one step. It's only step one. If you want to see the overhead field footage showing how to lay, step and wire a massive commercial 400 amp parallel conductor service base, head directly over to my channel homepage right now and watch the complete masterclass video we dropped yesterday morning. Hit subscribe, turn on all notifications, stay safe out on your job sites, and I'll see you brothers on the next drop. Shutting it down now.